Hi all of you. Today we learn most important things about electrochemical cell. It means how do the electrodes act, as one is as anode, another is as cathode. It depends upon its reactivity. As I told that more reactive metal always acts as anode. It loses electrons. Less reactive metal acts as a cathode. It gains electrons in the solutions, in their respective solutions. So students must know this mechanism. Then only you can understand which electrochemical cells are good or better ones. Then we can compare. Now let us take once again a cell, electrochemical cell, which contains two half cells. One is oxidation of cell, another is reduction of cell, because name of the half cell depends upon its nature only. For example, best example ours is zinc copper electrochemical cells. Zinc and copper, that is nothing but Daniell cell. In the Daniell cell we take a zinc rod and a copper rod, where zinc rod acts as a anode, whereas copper rod acts as a cathode. Now you should understand these are dipped in their salt solutions. Zinc means we take in zinc sulfate solutions, which produces Zn plus 2 ions and SO4 minus 2 ions. In the same way, copper rod is dipped in copper sulfate solution, which produces copper ions and sulfate ions. In the solution, copper sulfate we take. Okay. This type of reaction is spontaneous. Spontaneous reaction takes place. Because of the spontaneous reaction only energy is produced in the form of electricity. So these two zinc rods are connected externally with a metallic wire, for example copper wire. It contains a voltmeter, and these two solutions are connected by or joined by a salt bridge, which helps for the flowing of ions only, but not solutions, just to complete the circuit and to allow the ions to flow from one solution to another solution. So this is the simple construction of a Daniell cell, electrochemical cell. Yes, now we should know that what happens in this solution, what happens in this solution or half cell. This is called oxidation of cell. Oxidation of cell. This is a reduction of cell. Reduction of cell. Why oxidation of cell it is called? Because oxidation reaction takes place. For example, Zn metal is there. It loses 2 electrons and gives Zn plus 2 ions. Gives out Zn plus 2 ions in the solution. Means from the rod, Zn plus ions are dissolved in the solution. Arrow mark into the solution. It means zinc ions are produced from the rod, and minus 2 electrons also are produced. Minus 2 electrons. Each atom in the zinc rod loses 2 electrons, leaving Zn plus 2 ions into the solution. This happens. Everybody should understand. Now, opposite reaction takes place here. Electrons flow. What is yes, electrons flow from? Yes, Zn atoms losing 2 electrons. Electrons flow from this direction. This direction. Yes, electrons flow from left to right. It is a convention to show that the anode left side only. According to the UPAC convention, we should show anode on our left. Okay. Cathode on our right. That is the UPAC convention to represent the electrochemical cell. Now what happens? Electrons are flowing. Current flows always in opposite direction. We know that. Current. Now what happens here? Mechanism we are going to learn. So please concentrate on the mechanism only. Why it becomes it becomes anode? Why it becomes cathode? What is its charge also? Yes. Now Zn plus 2 ions are going into the solution, leaving 2 electrons. So this rod becomes negatively charged. A rod which is negatively charged is taken as considered as anode. So be very clear in this point. Because of losing 2 electrons, this zinc rod becomes an anode. But here, electrons are flowing into this, and Cu plus ions, electrons are coming into this rod, and these 2 electrons are gained by our copper ions. Copper deposited on this rod. Copper deposit, opposite here. Ions are produced into the salt solution. Here, copper ions are deposited on the rod, copper rod. Opposite reaction. It means here reduction reaction. Cu plus 2 ions gain these 2 electrons produced in the anode gained by copper ions, giving a copper solid. Here aqueous, here solid. Here these are aqueous. Ions always we should show aqueous condition. Aqueous salt solution there. So these are the oxidation of reaction, reduction of reaction. You should be very confident, everybody should be. Now, what happens is the potential difference, how does it occur? Let us see. If you know this one, you will be very clear in the electrochemistry. This only will make the students confused. So, without any confusion, you can better understand now. What happens here? Yes, here only salts we take, ionic only, ions only produce. Now, ions only allow from one solution to another solution only. This salt bridge function is. Now, what is here? This becomes negatively charged. But here, copper plus 2 ions are deposited. So, this rod becomes positively charged. Means it is anode, it is cathode. It is a cathode. So, this reaction takes place until it gets equilibrium. And whenever it gets equilibrium, then the potential difference between this rod and salt solution takes place. Potential difference between this rod and its salt solution. Sufficiently, it gets negatively charged. Sufficiently, it also gets a positive charge. So here also potential difference takes place here. So finally, at equilibrium, this becomes negatively charged, this becomes positively charged, as I told. Yes, now the potential difference between these two is called electrode potential of the cell. Electrode potential of the cell. This electrochemical cell, that is also called EMF, electromotive force of the cell. Generally, we calculate in the unit concentration of these ions, then we call it a standard electrode potential. Standard electrode potential, it is also called. These standard electrode potentials according to UPAC, we mention it a reduction potential only. So we don't mention reduction word. If potential electrode potential means it is reduction only. So this has a negative reduction potential, this has a positive reduction potential. So difference between we can see in the voltmeter, in the units of volts. How much potential difference occurs between the two of cells, it is we can measure by using the voltmeter. It will give the numerical measurement, quantitative measurement of the electricity produced in the circuit or flowing in the circuit is given by this voltmeter in volts. At standard condition of zinc and Daniel cell, zinc and copper, at a standard condition its value is 1.1 volts. 1.1 volts. At stand, that is called E naught of the cell. Naught means standard EMF of the cell, Daniel cell. At a standard condition means you know that the temperature at absolute temperature, that room temperature only, standard conditions. So at standard condition, unit concentration and standard temperature. At this condition, the potential difference is called standard potential of the electrochemical cell. See, this is the potential difference occurs between these two rods. Generally, not generally, compulsory, this is more reactive, this is less reactive. Then only, greater the positive value of the inert cell, it is a better electrochemical cell. Always it should be positive. It never be negative. Electrochemical cell, its a EMF value always it is a positive only, never be negative. You should understand this. Thank you all. I hope you have understood.